Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students today? This is the third lecture of grade first year. The chapter name is Solution and Colloids and the topic name is Colloids, Properties and Types of Colloids, Heat of Solution. What are colloids? Colloids are the mixtures of two substances which are intermediate between true solution and suspension. The particles in such a mixture are smaller than those in a suspension, but larger than those in the true solution. The colloid particles are larger than the true solution and smaller than the suspension. The name colloid was coined by the Graham. The Greek word kolla, which means glue, and eidos mean like. Colloids are the substances consisting of a continuous homogeneous medium known as dispersion medium and particles of a discontinuous medium termed as dispersed medium or the inner phase. For example, the milky dispersion of sulfur, starch, gum in water and blood, serum. So colloids are the type of mixture. It is composed of two phases, dispersion medium and the dispersed phase. Colloids are the mixture in which dispersion phase is evenly distributed in the dispersion medium. I have already told you that colloids is derived from a Greek word kolla, which means glue-like. They have slower rate of diffusion and cannot diffuse from the parchment paper. Parchment paper is actually the baking paper and it is used for baking purposes in your houses. Colloidal system can be solid, liquid or gaseous. The examples include starch, gelatin, gums and hemoglobin, etc. So the colloidal system include a dispersion phase and a dispersion medium. There are some properties of colloids. The first is optical properties. Optical properties is mainly relating with the Tyndall effect. The Tyndall effect is about scattering of light. The scattering is the appearance of light away from the normal optical path due to interaction between light and particles. If the particles are of colloidal size, we see the light scattered in all directions because colloid is the intermediate between true solution and suspension. So the light scattered in all directions. This effects explain the tail of comet or the Tyndall effect and blue color of the sky is because of scattering. When an intense converging beam of light is passed through a colloidal solution kept in dark, the path of the beam gets illuminated with a bluish light. This is because of scattering of light and tail of comet, which is generally called as Tyndall effect. Second is Brownian movement. The random movement of particles in zigzag path is called as Brownian movement. The random movement of particles suspended in liquid or gas is called as Brownian movement. The colloidal particles are moved on zigzag path. This movement is called as Brownian movement. Brownian movement may be used to distinguish between solutions and colloids. It is the random movement of colloidal particles suspended in dispersion phase or medium. Particles of colloids are larger than that of solution, that they resist settling rapidly to the bottom of the vessel due to Brownian movement. The colloidal particles are bombarded by the other fast moving molecules of the medium and thus change their direction of movement. This is due to zigzag path. The higher the temperature, the more vigorous is the movement and hitting by the molecules. A zigzag motion of colloidal particles can be observed by an ultramicroscope. The continuous zigzag movement of the colloidal particles in the dispersion medium in a colloidal solution is called as Brownian movement. Third property is filterability. Colloidal particles cannot be separated by ordinary filtration. Due to their small size, the colloidal particles pass through an ordinary filter paper. However, they can be retained by animal membranes, cellophanes membrane and ultrafilters. Colloidal particles cannot be separated by ordinary filtration, but these particles can be removed generally by specially designed filters of extremely fine porosity called as ultrafilters. Porosity is the ability to form pores. This process of separation of colloidal particles by ultrafilters is called as ultrafiltration. Next property is color. The color of colloidal solution depends upon the size and shape of the colloidal particles and the wavelength of scattered light. For example, silver soles with different particle size show different colors. Here is another property which is called as diffusibility. The colloidal particles have very large size as compared to the ordinary solute particles, hence they have little power of diffusion. What are the applications of colloids? Colloids are used in foodstuffs and medicines. Many of our foodstuffs are colloidal in nature, that is milk, butter, whipped cream, starch, sugar, fruit jellies, ice cream, bread, etc. are all colloidal in nature. For example, milk is an example of butter, fat and water, stabilized by milk protein casein. Ice cream is a dispersion of colloidal ice particles in cream. Similarly, bread consists of air dispersed in baked dough. There are two types of colloids, that is lyophilic colloids and lyophobic colloids. What are the lyophilic colloids? Lyophilic means liquid loving or solvent attracting. If the dispersion medium is water, then the term hydrophilic colloids is used. The dispersion medium, that is water, comes in contact with the dispersed particles. If the dispersion medium, that is water, and the dispersed particles attract with each other, it means that it is water loving colloids, and we can name them as lyophilic colloids. Whereas lyophobic colloids are those which are water fearing or water hating. The colloid is called lyophobic if the dispersed particle has little or no affinity for the dispersion medium. That is, the water will not attract with the dispersed particles and there will be no attraction between water and the dispersed particles. So this is liquid fearing or solvent hating. The lyophilic colloids are called as reversible colloids, as we have already studied in the class that lyophilic colloids are the reversible colloids. When they form precipitate, they can again be converted into their original positions. The precipitate can again be converted into the colloids. Whereas lyophobic colloids are the irreversible colloids. They cannot be converted back into colloids after formation of precipitates. So the lyophilic colloids or hydrophilic colloids are much stable as compared to the lyophobic or hydrophobic colloids. The examples are solutions of metals like silver and gold, solutions of metal hydroxides such as aluminium trihydroxide. Moreover, homogenized milk and lassi, which is casein suspended in water, are the examples of hydrophilic and hydrophobic solutions respectively. The last topic is heat of solution and its applications. Heat of solution is also known as enthalpy. The heat of solution is defined as amount of heat evolved or absorbed. It means the reaction can be exothermic or endothermic. So the heat of solution is defined as the amount of heat evolved or absorbed when 1 mole of a substance is completely dissolved in large amount of solvent. We have taken the 1 mole of solute or the substance which is completely dissolved in large amount of solvent at constant temperature and pressure. At this stage, the amount of heat evolved or absorbed is called as heat of solution. So when substances dissolve in water, an energy change usually occurs. Enthalpy of solution is defined as the enthalpy change when 1 mole of a substance completely dissolves and the heat is evolved or released. This is called as enthalpy or heat of solution. For example, if solid sodium hydroxide is dissolved in water, the temperature of water will rise due to increase of the base sodium hydroxide. It means the energy gets released and this is an exothermic process. On the other hand, ammonium nitrate, when dissolved in water, the temperature of water gets decreased. This means that heat is absorbed and the process is endothermic process. That is, heat is either absorbed or evolved during the process of dissolution. Heat is absorbed when solute reacts with solute or solvent reacts with the solvent. In the result, the heat will absorb. Del H means heat of solution will be positive and the process will be endothermic. On the other hand, when solute and solvent will attract, the solution will form, temperature will increase, del H will be negative and the process will be exothermic. So here are some examples of the exothermic reactions. HCl to form HCl. Del H solution is negative, mean heat is released in the presence of aqueous solution or water. Solute and solvent reacts, energy released, del H negative, and the process is exothermic. This was all about heat of solution. Thank you so much.